A hidden giant lurks at the edges of our solar system, silent, unseen, and potentially reshaping everything we think we know about our cosmic neighborhood. NASA's telescopes and deepest observations have hinted at its existence for decades. Yet Planet 9 remains one of the greatest mysteries in astronomy. What if this mysterious world isn't just a job for scientists, but a key to understanding the very fabric of our solar system's past and future? Stay tuned, because unlocking this enigma could change everything about our place in the universe. The origins of the Planet 9 hypothesis. The notion of an unseen massive planet lurking on the fringes of our solar system emerged from a combination of meticulous observation and the persistent curiosity of astronomers. As bodies orbiting the sun were tracked over decades, subtle discrepancies in their paths began to surface, anomalies that defied explanation by known gravitational influences alone. These irregularities, especially apparent in the distribution and trajectories of distant Kuiper Belt objects, hinted at something sizable beyond the reach of Neptune, exerting a gentle but persistent tug on distant celestial objects. The initial clues came from careful analysis of the orbits of several extreme trans-Neptunian objects, which showcased clustering patterns inconsistent with mere chance. Researchers noted that many of these icy bodies seemed to point towards a common area in space, almost as if an invisible shepherd was directing their orbits. These clues ignited a spark among the scientific community, prompting speculation about an undiscovered planet, one with enough gravity to influence the collective movement of these distant objects. Although the evidence was indirect, it was compelling enough to warrant serious consideration, especially given the precision of modern astronomical observations. As the search intensified, some researchers turned to computer simulations, powerful tools capable of modeling the gravitational interactions in vast, complex systems. When they introduced hypothetical massive objects into their models, the simulated orbits of distant Kuiper Belt objects aligned more closely with observed patterns. This convergence of observational anomalies and computational modeling strengthened the case that a substantial, yet unseen, planetary body might be shaping the architecture of the far reaches of our solar system. The hypothesis was no longer just a speculative idea, but an emerging scientific paradigm, grounded in data-driven reasoning and the ongoing quest for kinematic coherence. NASA's ongoing surveys and deep space imaging have played a pivotal role in this investigation, pushing the boundaries of what can be observed and hypothesized. Despite the lack of direct visual evidence, the convergence of orbital anomalies, modeling results, and the limitations of current detection technologies keep the hypothesis alive. Each new deep sky survey and refinement of orbital data fuels the suspense, reminding us that the outer solar system still guards secrets, possibly including one of its largest, yet-to-be-confirmed inhabitants. The origins of the Planet 9 hypothesis remain a testament to the power of curiosity and the relentless pursuit of understanding our cosmic neighborhood. Early clues from the Kuiper Belt. In a vast expanse beyond Neptune, the Kuiper Belt acts like a cosmic scrapyard filled with icy remnants from the solar system's infancy. It's here that early anomalies first caught NASA scientists' attention, hinting at something far more massive lurking in the dark. Observations of Kuiper Belt objects, KBOs, revealed peculiar patterns, especially in their orbital paths. Some objects moved in ways that defied expectations, suggesting gravitational influences far stronger than the known planets could account for. These irregularities didn't emerge randomly. They pointed towards the gravitational tug of an unseen force, an unknown planet, perhaps, or a complex gravitational disturbance. Astronomers noticed that several distant KBOs shared similar orbital characteristics. They clustered at similar inclinations and resonances, orbiting the Sun in ways that hint at a common invisible influence. These alignments and groupings weren't easily dismissed as chance. NASA's observations, particularly through the utilization of powerful telescopes and detailed simulations, suggested a gravitational shepherd, something large enough to mold KBO trajectories over millions of years. The clues appeared subtle at first, but grew more compelling as datasets expanded. This was no isolated mystery, but a pattern coded into the structure of the outer solar system, waiting for interpretation. Further analysis uncovered that these gravitational effects weren't just a statistical fluke. The orbits of certain objects had significant eccentricities, extended paths that pulled them into elongated ellipses, another potential sign of a colossal, yet unseen, influence. When scientists modeled the movements of these distant bodies, the only plausible explanation involved a hefty mass lurking in the far reaches of the solar system, exerting its sway over the smaller, icy objects. NASA's team considered possibilities ranging from a very large planet to a population of dwarf planets or even a dark matter concentration. The potential for a Planet 9 emerged from these earliest clues, wrapped in a fabric of orbital anomalies. What makes this investigation all the more tantalizing is how persistent and consistent these early clues are. The gravitational signatures from multiple KBOs appear to point toward a common source, something far bigger than anything known orbiting the Sun. NASA's initial reports highlighted the importance of these orbital peculiarities, framing them as signatures waiting to be deciphered. While technology at the time couldn't yet directly detect this mystery companion, the patterns in the Kuiper Belt kept the scientific community intrigued. Each new observation added layers of complexity, and with every dataset, the possibility of a hidden planetary giant lurking at the solar system's edge grew harder to dismiss. These early signals from the Kuiper Belt, subtle yet persistent, laid the groundwork for what many now consider to be one of the greatest cosmic mysteries of our time: unusual orbits of distant objects. Among the most compelling clues pointing toward the existence of Planet 9 are the peculiar orbits of distant trans-Neptunian objects. These are icy bodies lurking beyond Neptune, some of which exhibit highly elongated and clustered trajectories that defy the gravitational influences of the known planets. Researchers observed that several of these objects, such as Sedna and 2012 EP-113, follow paths that seem to be aligned in a way unlikely to be mere coincidence. Instead, their orbital patterns suggest an unseen, massive perturber exerting a subtle but persistent tug. This anomaly has become one of the strongest indirect hints supporting the hypothesis that a large, hidden planet lurks far beyond Pluto. What makes these orbital anomalies particularly captivating is their coherence over millions of years. Many of these bodies have perihelia, closest approach points to the Sun, that are surprisingly aligned, despite their vast differences in distance and orbital period. Astronomers like Konstantin Batygin and Michael Brown at Caltech have conducted dynamical simulations showing that a massive object, roughly 5 to 10 times the mass of Earth, could shepherd these objects into their current arrangements through gravitational influence. This scenario is reminiscent of how Neptune's gravity influences the Kuiper Belt, but on a much larger and more enigmatic scale. The extent to which these distant orbits are clustered suggests a purposeful gravitational mechanism rather than chance. NASA's ongoing surveys and advanced telescopes have yet to capture Planet 9 directly, but the persistent orbital conundrum keeps it squarely in the scientific spotlight. The peculiarities are not just random fluctuations. They form a pattern, a celestial dance choreographed by an unseen partner. The potential presence of this planet acts as a keystone in understanding the wider architecture of our solar system's frontier. Without direct observation, researchers rely heavily on orbital mechanics and computer models to infer the planet's possible properties and position, making the mystery even more tantalizing. The discovery of a planet in such a remote and harsh environment would be revolutionary, yet the evidence remains circumstantial. Still, these unusual orbital patterns pose a significant challenge to current planetary models. Each new object found in the Kuiper Belt adds a piece to the puzzle, and the coherence of their orbits keeps the mystery alive. Whether or not NASA's next observatory identifies Planet 9, the orbital oddities alone magnetize astronomers and keep the quest for this elusive world at the forefront of planetary science. The search begins. Initial surveys and challenges. NASA's quest to uncover Planet 9 has been anything but straightforward. The initial surveys relied heavily on analyzing the extensive data collected by observatories and telescopes arrayed across the world. Astrophysicists and planetary scientists pored over decades of telescope images, seeking faint, slow-moving objects hiding in the distant reaches of the solar system. The challenge lies in the fact that Planet 9, if it exists, would orbit well beyond Neptune, cloaked in an immense region of darkness and distance where sunlight barely penetrates. This makes detection incredibly difficult, especially because even massive objects at such distances reflect only a tiny fraction of the light hitting them. Early efforts focused on tracking peculiarities in the orbits of trans-Neptunian objects, TNOs. These small bodies exhibit unusual clustering patterns, which some scientists interpret as indirect evidence of a massive gravitational influence, potentially from a large, unseen planet. However, confirming its presence through telescopes alone posed enormous hurdles. The sheer size of the search area is daunting. With no precise data on the planet's location, astronomers had to scan vast swaths of the sky, an almost Herculean task given the limits of observational technology and available telescope time. This required sophisticated algorithms to sift through mountains of data and flag possible candidates for further investigation. Moreover, conditions during the initial surveys created additional obstacles. Cloud cover, atmospheric disturbances, and the inherent faintness of distant objects often caused promising signals to fade or go unnoticed. The United States' major observatories, like the Subaru Telescope in Hawaii, participated in targeted surveys, but the vastness of the search space meant that many promising leads were lost in a sea of noise. Challenges also arose from the fact that the hypothetical Planet 9 might be moving very slowly across the sky, stretching the limits of motion detection algorithms. The hunt was akin to trying to find a needle in a cosmic haystack, with each new survey adding pieces to the jigsaw and revealing more about the immense difficulty involved. Despite setbacks, these initial efforts established a foundation of knowledge and technological capability that would inform future searches. NASA and its collaborators refined their computer models, making more accurate predictions about where the planet might be hidden. They also began developing more sensitive detectors and adopting novel observational techniques, like stacking multiple images to increase the chances of detecting faint objects. Still, the mystery persisted, as each survey seemed to deepen the enigma rather than resolve it. The obstacles transformed from mere technical challenges into the very essence of one of the greatest celestial puzzles of our era, fueling speculation and sparking relentless determination to persevere in the search. NASA's role in the investigation. In the quest to unravel the mystery of Planet 9, NASA has positioned itself as the pioneering force navigating the unknown. While direct observation remains elusive, no spacecraft has yet pierced the distant reaches where this hypothetical planet is believed to linger. NASA's influence manifests profoundly through data analysis, observational strategies, and technological innovation. The agency's telescopes, both space-based like the Wide Field Infrared Survey Explorer, WISE, and ground-based observatories, have been tasked with scanning the outskirts of our solar system. These instruments aim to detect faint infrared signals or gravitational signatures that could betray the presence of a large celestial body lurking beyond Neptune. Such efforts are relentless, often involving sophisticated algorithms capable of filtering out the cosmic clutter and pinpointing anomalies consistent with a planet-sized object. In addition to passive observation, NASA scientists actively contribute through theoretical modeling and simulation. By analyzing the orbital behaviors of existing trans-Neptunian objects, small bodies that orbit beyond Neptune, they attempt to piece together the gravitational puzzle that Planet 9's existence would create. The irregularities in these distant objects' paths have been key indicators. Subtle deviations suggest the influence of an unseen mass exerting gravitational pull. NASA's role here is to refine these models, improve the accuracy of predictions, and guide targeted searches. Their computational prowess allows scientists to sift through vast data sets, prioritizing observational campaigns that could confirm or refute the planet's existence. Furthermore, NASA's collaborative efforts extend beyond the confines of their own facilities. The agency shares insights with international partners and advocates for the development of next-generation telescopes designed specifically to hunt for distant, dim objects. Missions planned for the future, such as the Vera-C Rubin Observatory, are partly inspired by NASA's pioneering work, promising deeper and more comprehensive all-sky surveys. These projects aim to push the boundaries of what is detectable, inching closer to possibly capturing direct evidence of Planet 9. Every data point collected, every model tested, and every new technology deployed enhances NASA's role as the central authority in this cosmic investigation. In the midst of whispers and speculation, NASA's unwavering commitment keeps the possibility alive, an ongoing pursuit of one of the most tantalizing mysteries in our solar system. Methods and technologies used in detection. In the intricate pursuit of unveiling Planet 9, scientists rely heavily on gravitational effects observed within the distant reaches of our solar system. Instead of directly viewing the hypothesized planet, researchers analyze the orbits of Kuiper Belt objects, small icy bodies orbiting beyond Neptune. Subtle deviations in their trajectories offer clues that something massive lurks far out in the dark, unseen by current telescopes. These anomalies suggest the presence of a substantial body exerting gravitational pull, subtly tugging on objects at the fringes of the solar system. This method hinges on precise calculations and extensive analysis of orbital mechanics, demanding high-fidelity data gathered over many years. Complementing these indirect observations, astronomers harness the power of advanced computational models that simulate the gravitational landscape of the outer solar system. By inputting observed orbital deviations into sophisticated algorithms, they attempt to infer properties such as the potential planet's mass, orbit, and distance. These models are continually refined by the data collected from telescopic surveys, enabling scientists to narrow down the parameter space for Planet 9. The iterative nature of this approach, combining observational data with theoretical simulations, has been crucial in shaping ongoing search strategies and refining the candidate regions in the sky. On the technology front, NASA and other space agencies employ powerful radio telescopes and large ground-based optical observatories equipped with highly sensitive CCD, charge-coupled device, cameras. These instruments scan vast swathes of the sky with meticulous precision, seeking any faint, slow-moving objects that could indicate a distant planet. For example, surveys like the Dark Energy Camera, DCAM, and the Subaru Telescope's Hypersuprime Cam have been used in this endeavor, leveraging their enormous fields of view and deep imaging capabilities. Despite not capturing Planet 9 directly yet, they help rule out or narrow down regions where the planet might be hiding, based on where it isn't. In recent years, innovative use of infrared astronomy has also entered the fold. Since a planet of planetary size, but with a distant, cold orbit would emit very little visible light, infrared telescopes like NASA's NEOWISE mission become vital tools. These instruments scan the sky for faint thermal signatures that might reveal a cold, distant body otherwise hidden from optical surveys. The challenge remains immense. The potential planet's faint glow can be lost in the noise, requiring massive data processing capabilities powered by machine learning and AI algorithms. These efforts push the boundaries of detection technology, inching us closer to either confirming or dismissing the existence of Planet 9. Possible locations and search strategies. The hunt for Planet 9 intensifies as scientists speculate its vast orbit lurking beyond Neptune, but pinpointing its location remains an enormous challenge. Theories suggest that if it exists, this mysterious body could be orbiting far out in the Kuiper Belt or even beyond the scattered disk, regions heavily influenced by past gravitational interactions with Neptune and other distant objects. These areas are characterized by sparse and faint objects, making detection a task akin to finding a needle in a cosmic haystack. Researchers leverage the gravitational effects observed in the orbits of trans-Neptunian objects, TNOs, which seem to subtly wobble under the influence of an unseen mass. The clues point towards a region of the sky where the distribution of long-period comets and minor planets appears skewed, hinting at a massive presence lurking on the fringes. Search strategies being employed are as innovative as they are meticulous. NASA's data from wide-field surveys, such as the Dark Energy Camera mounted on the Victor M. Blanco telescope, form the backbone of this quest. By systematically imaging large swathes of the sky and comparing observations over time, astronomers can identify objects moving slowly against the stellar background. Given Planet Nine's hypothesized distance, possibly hundreds of astronomical units, its slow motion relative to closer objects demands patience and precision. Computer algorithms sift through terabytes of data, seeking faint trails and subtle shifts, while machine learning techniques help differentiate between potential planet candidates and background noise. Emphasis is placed on regions where gravitational models predict the planet's presence, narrowing down search zones to maximize efficiency. The intersection of orbital dynamics and observational astronomy guides efforts to refine possible regions further. Simulations based on Newtonian physics suggest that Planet Nine's orbit would be highly elongated, inclined, and slightly tilted relative to the plane of our solar system. This insight directs telescopes toward specific regions near the ecliptic but at higher latitudes, places where prior surveys might have overlooked faint objects. Future missions and observatories, such as the Vera C. Rubin Observatory, are poised to revolutionize the approach. Its unparalleled sensitivity and rapid survey cadence could offer the breakthrough needed to detect slow-moving, faint planetary bodies at extreme distances. Meanwhile, astronomers remain vigilant, continuously refining their models and attack strategies, turning every night's observation into a potential discovery. The unknown remains tantalizingly close. Each new image could inch humanity closer to confirming one of the solar system's greatest mysteries. Evidence supporting Planet Nine's existence. Hidden within the intricate choreography of distant celestial objects, subtle gravitational nuances whisper secrets about something lurking far beyond Neptune's orbit. Astronomers have noted that the orbits of several trans-Neptunian objects, TNOs, exhibit peculiar alignments that defy the expectations set by known planetary bodies alone. Many of these icy bodies, orbiting in the Kuiper Belt, show a surprising degree of clustering, their perihelia pointing toward a common region in space. This anomaly has prompted vital calculations and simulations suggesting the gravitational pull of an unseen massive object, a candidate for Planet Nine, distorting their paths with a quiet, persistent hand. Repeated observations for years have reinforced the case. Researchers at NASA and other space agencies have analyzed the orbital arcs of these distant objects, employing powerful telescopes and advanced computer models to understand their motion. These models reveal that without a substantial source of gravity, the observed clustering diminishes rapidly over time. The only viable explanation remains a massive, yet unseen, planetary body exerting influence from the fringes of our solar system. Such a body, billions of miles away, would be too faint to detect directly in most cases, reinforcing why it remains hidden. Still, its gravitational signature persists, subtly shaping the paths of objects that are otherwise considered too distant and faint to fully study. Further compelling evidence comes from the detailed orbital dynamics of some of the most distant Kuiper Belt objects. These bodies, with their extreme elliptical orbits and unusual inclinations, cannot be easily explained by interactions with known planets alone. Instead, simulations show that a single, massive perturber orbiting far beyond Neptune could account for their peculiar alignments. NASA's own research teams have modeled these scenarios, providing statistically significant support for the existence of Planet Nine, with various proposed masses and orbital configurations still consistent with current observational data. The persistence of these orbital anomalies across multiple datasets strengthens the case, not as proof, but as a compelling piece of a larger cosmic puzzle. The quest for evidence extends further into the realm of observational astronomy. Despite the faintness and vast distance, astronomers continue to hunt for direct signals of the elusive planet. Some recent surveys have narrowed down the sky regions where Planet 9 could be hiding based on the gravitational footprints it leaves behind. The possibility of future telescopes, equipped with more sensitive detectors, detecting its reflected sunlight or thermal emissions remains a tantalizing frontier. Until then, the gravitational footprints and the peculiarities of distant objects serve as the strongest silent witnesses to a possible ninth planet, one that challenges our understanding of the solar system and beckons us to look deeper into the dark, quiet outskirts of space. Alternate theories and skepticism. Some skeptics argue that the evidence supporting Planet 9 remains more circumstantial than conclusive, casting doubt on the very existence of this distant celestial body. While NASA astronomers have observed peculiar clustering in the orbits of several trans-Neptunian objects, critics contend these patterns could emerge from less exotic causes, such as observational bias or the gravitational influence of multiple smaller bodies rather than a single massive planet lurking beyond Neptune. Doubters point out that despite extensive searches, no direct imaging or unequivocal detection of Planet 9 has been achieved, raising questions about whether the hypotheses are premature or rooted in pattern-seeking rather than solid evidence. Moreover, alternative theories challenge the notion of a ninth planet on purely scientific grounds. Some propose that what we interpret as orbital clustering may instead be a result of the solar system's formative environment, fossil remnants from the early protoplanetary disk, or the gravitational imprint of passing stars. These hypotheses suggest that the complex gravitational interplay among smaller objects could mimic the effects attributed to a planetary-sized body, thus undermining the necessity of postulating a planet that remains elusive to our current detection methods. Such ideas keep the mystery alive without definitively confirming the presence of Planet 9. Another layer of skepticism arises from the practical challenges inherent in discovering this distant object. The hypothetical planet could be hundreds of astronomical units away, dimmer than most of the objects we have cataloged, even with powerful telescopes. NASA's existing instruments, including the Vera-C Rubin Observatory, whose survey capabilities are expected to dramatically enhance our ability to find faint objects, may still face limitations due to the planet's potential low reflectivity or unusual orbit. Critics argue that if Planet 9 exists, it may be simply too faint, too distant, or too hidden behind the cosmic dust to be detected with current technology. Finally, some researchers emphasize that the focus on Planet 9 may reflect a human tendency to seek celestial culprits for orbital puzzles rather than a definitive astrophysical phenomenon. The dynamic and often unpredictable motions of small bodies in the Kuiper Belt evoke a natural curiosity, but also foster confirmation bias. NASA remains cautious. While their models comfortably incorporate the possibility of a hidden planet, the agency openly admits that more data are needed before firm conclusions are drawn. The ongoing debate fuels the sense that this mystery remains tantalizingly out of reach, a cosmic enigma still shrouded in shadows of doubt. Historical context of planetary discoveries. Throughout the ages, humanity's quest to understand the cosmos has been marked by a blend of curiosity, innovation, and often serendipity. Early astronomers relied solely on naked-eye observations, charting the movements of planets like Mars, Venus, and Jupiter with primitive tools and keen eyes. The advent of telescopes in the 17th century transformed this exploration. Galileo's pioneering work bringing the moons of Jupiter into view and solidifying the heliocentric model. With each technological leap, the universe expanded before human eyes, revealing worlds never glimpsed before and prompting a re-evaluation of our place among the stars. The modern era of planetary discovery took a decisive turn with the space age. NASA's progenitors, motivated by both scientific curiosity and strategic interest during the Cold War, launched a series of missions that revolutionized our understanding of the solar system. The Voyager probes, for example, expanded horizons beyond the known planets, capturing detailed images and analyzing distant worlds. Yet, despite remarkable progress, the outer reaches of our planetary neighborhood still held secrets. The recognition of Pluto as a dwarf planet, reclassified after decades of classification, exemplifies the ongoing evolution of what scientists thought they knew about our planetary family. Interest in the farthest regions of the solar system intensified as astronomers detected anomalies in the orbits of some trans-Neptunian objects. These irregularities suggested gravitational influences from an unseen mass, a potential signpost for a new planet lurking at the fringes. NASA and other space agencies began pooling data, harnessing advanced computer modeling to simulate how a massive object might influence the orbital dance of distant icy bodies. This collective effort, rooted in decades of planetary research, continually pushed the boundaries of what was considered possible. The idea of an undiscovered Planet 9 emerged from this careful synthesis of observation and theory, intriguing scientists and the public alike. The pursuit of Planet 9 feels like a natural continuation of humanity's innate drive to uncover the unknown. For decades, the search has combined sophisticated optical surveys, gravitational studies, and cutting-edge algorithms to glimpse what cannot yet be seen. NASA remains at the forefront of this quest, with observatories and missions specifically tailored to detect the faint gravitational whispers of a shadowy, massive object. As technology advances, the mystery deepens. Each new discovery about the outer solar system hints that this hidden world may be more than just a mathematical hypothesis. It is a tantalizing echo of forgotten worlds, waiting patiently at the edge of our current reach, urging us toward the next great discovery. Implications for solar system formation. The potential existence of Planet 9 forces a re-evaluation of the classical narrative surrounding the birth and evolution of our solar system. Traditional models depict a relatively orderly process where the sun's protoplanetary disk gave rise to planets in a predictable, concentric manner. The hypothesis of a massive, unseen world lurking in the outer reaches challenges these assumptions, hinting at a more tumultuous, perhaps chaotic, early environment. The observed clustering of distant trans-Neptunian objects, in particular, suggests gravitational influences that cannot be easily explained by the known planetary lineup alone. Such influences imply that the solar system's formative processes may have involved complex interactions, including the early migration of giant planets and the potential capture or ejection of protoplanets. This mysterious planet's gravitational footprint could reveal clues about the particles and debris that shape the solar system's periphery. If Planet 9 exists, it might have played a pivotal role in sculpting the orbits of small bodies and dust clouds long after the initial planet formation. Simulations indicate that a substantial, yet unseen planet could have shepherded icy objects into stable, distant orbits, effectively acting as a cosmic gatekeeper. This raises questions about how planetary migration, the process by which giant planets might have shifted from their original positions, interacted with the surrounding disk of material. The resulting gravitational battlefield could have significantly altered the distribution of small objects, leading to the diverse architectures we observe today. Beyond mere orbital mechanics, the existence of Planet 9 could suggest that planet formation is not a straightforward, isolated process confined solely to the inner regions of a star's protoplanetary disk. Instead, it might involve the dynamic accretion and ejection of massive bodies over extended timescales. This complicates models that assume a neatly layered development akin to the orderly growth of terrestrial planets close to the Sun. Instead, it implies that some large planets might form quickly in the outer disk, remain on elongated orbits, or even be lost entirely, only to influence the system's evolution decades later. Such a paradigm shift could redefine how astronomers understand the initial chaos and subsequent settling of planetary systems, including our own. Furthermore, understanding if and how Planet 9 fits into solar system formation could have broader implications for comparative planetology. If our system's architecture was shaped by a massive external influence, it suggests that similar processes could operate in other stellar systems. Exoplanet surveys have already uncovered systems with unconventional configurations, super-Earths, distant giants, planets on eccentric orbits, hinting that our solar system might not be as unique as once thought. The presence or absence of Planet 9 could help calibrate models of how common or rare such planetary arrangements are, shedding light on the universality of planetary system evolution. NASA's ongoing efforts to confirm or refute the planet's existence remain pivotal in unraveling whether our solar system was a product of serene, gradual buildup or a chaotic, dynamic birth that still echoes through its distant outer reaches. Impact on current astronomical models. The potential existence of Planet 9 has ignited a seismic shift in contemporary astronomical theories, challenging long-held assumptions about the solar system's architecture. For decades, models have been predicated on the idea that the orbital dynamics of trans-Neptunian objects, TNOs, follow predictable patterns shaped primarily by the known planets. The clustering of certain distant Kuiper Belt objects, however, defies these predictions. When scientists observe that multiple TNOs share aligned orbital planes and eccentricities inconsistent with the gravitational influence of the others, suspicions grew. Such anomalies could point toward an unseen, massive object exerting a gravitational tug, a possibility that redefines the boundaries of current models. NASA's own studies have prioritized these orbital peculiarities, emphasizing how they push the boundaries of existing theories about planetary formation and stability. Researchers now grapple with incorporating this mysterious influence into the classical models of the solar system's formation. Traditional models rely heavily on the idea that planetary orbits have stabilized after chaotic early days, with no large, undiscovered planets lurking at the fringes. The potential presence of Planet 9 suggests that the outer solar system still holds secrets that could rewrite this narrative. If a body several times more massive than Earth resides beyond Neptune, it might have played a significant role in shaping the early dynamical history, affecting migrations or gravitational interactions that standard models simply cannot explain without its inclusion. This raises questions about how many other unseen masses could exist, lurking on the periphery and influencing orbital mechanics in ways that were previously unimaginable. Furthermore, the suspected influence of Planet 9 compels astronomers to revisit simulations of solar system stability. Many models assume a diminishing gravitational influence with increasing distance, but the clustering phenomena imply a more complex gravitational landscape. Incorporating a hypothetical ninth planet into these simulations alters the expected trajectories of small bodies, leading to entirely new hypotheses about their origin and evolution. NASA's detailed orbital analyses of distant objects have begun to produce models that attempt to reconcile these irregularities, yet consensus remains elusive. The possibility that our current understanding of planetary interactions might be incomplete permanently alters the way scientists approach the dynamics of not just our solar system, but planetary systems in general. Tied to this is the challenge of probabilistically mapping the scope of the unknown. The suspicion of Planet 9 has prompted a reevaluation of observational strategies and theoretical frameworks, fostering a sense of both caution and curiosity. As astronomers sift through vast data sets from wide-field surveys, like those from the Dark Energy Survey and upcoming facilities such as the Vera-C Rubin Observatory, they remain aware that each new data point could either confirm or refute the presence of this enigmatic planet. The stakes are high. Confirming its existence would reshape the narrative of planetary formation and require the overhaul of several core assumptions underlying current models. Conversely, its continued elusiveness forces a prudent recalibration, emphasizing the importance of integrating observational anomalies into the broader tapestry of celestial mechanics, guiding future predictions and explorations. Recent developments and future missions. Advancements in planetary astronomy have kept the search for Planet 9 firmly on the scientific radar, with recent studies sharpening the focus rather than dimming it. NASA's data analysis teams and international collaborators continue to sift through the outskirts of our solar system, teasing out subtle gravitational influences that could betray the presence of this elusive world. Although no direct image exists of Planet 9 yet, researchers point to peculiar orbital clustering among distant trans-Neptunian objects as compelling indirect evidence. These anomalies suggest a massive body lurking beyond the known planets, potentially several times Earth's mass, subtly tugging on known small bodies in the Kuiper Belt. Cutting-edge simulations and mathematical models now lend tighter constraints to where Planet 9 might be hiding, narrowing the search parameters significantly. NASA's upcoming missions and observational strategies reflect a growing urgency and sophistication, embracing novel techniques to probe the deep solar system. Ground-based telescopes equipped with advanced instrumentation, like the Vera-C Rubin Observatory, are poised to revolutionize our ability to scan the far reaches of space with unprecedented sensitivity. These observatories aim to detect faint, slow-moving objects, possible candidates for Planet 9, that have so far remained invisible amidst the cosmic glare. On the space exploration front, proposals for dedicated missions are beginning to stir, contemplating the deployment of specialized probes to explore the outer solar system's gravitational landscape. Although no mission has yet been officially greenlit for Planet 9 specifically, NASA's planetary defense and deep space reconnaissance units are diligently developing technologies that could eventually be used in such endeavors. The future of this search hinges on the continuation of refining observational techniques and technological innovation. Researchers are considering the possibility of deploying spacecraft that could approach the suspected orbital zone and gather direct data, much like missions that have explored distant planets and moons. Meanwhile, theoretical work persists, aiming to understand how a planet of such size could influence the solar system's architecture without yet being captured by current telescopic scans. The mystery deepens as scientists debate whether a long-failed detection attempt indicates a truly hidden planet or suggests the influence of more complex gravitational phenomena. As each new observation feeds into the collective puzzle, NASA's push for enhanced detection capabilities becomes more critical than ever. Throughout this unfolding narrative, the sense of suspense remains palpable. Every new scan, every refined model, brings us a step closer, yet still so far from certainty. It is this tantalizing proximity to discovery that keeps astronomers and enthusiasts riveted. Scientific teams are aware that a breakthrough could redefine our understanding of the solar system's structure and origins. With each technological leap and each faint celestial signal, the intrigue intensifies. The quest continues, and while the darkness conceals Planet 9's secrets, it also fuels the relentless human desire to uncover the unknown. NASA's dedication to solving this cosmic mystery underscores that the greatest discoveries often emerge from the shadows, waiting to be brought into the light. Public and scientific community reactions. The idea of Planet 9 has sparked a tumultuous mix of intrigue, skepticism, and cautious optimism among both the general public and the scientific community. Since NASA's preliminary hints about an unseen massive body lurking beyond Neptune's surface, countless enthusiasts have flooded forums, social media, and news outlets with theories and speculation. To many space aficionados, the possibility of a hidden giant in our solar system feels both thrilling and tantalizing, a cosmic mystery that hints at the universe's deeper secrets. Yet, amidst this excitement, NASA remains notably reserved, emphasizing that while current gravitational anomalies hint at something substantial, definitive evidence remains elusive. This careful balance between speculation and scientific rigor fuels an undercurrent of suspense. Does NASA truly know more than it's revealing, or is this an ongoing quest riddled with false leads? The scientific reaction oscillates between cautious skepticism and genuine curiosity. Many astronomers acknowledge that the gravitational effects on distant Kuiper Belt objects do suggest a large, unseen mass influences their orbits. However, this evidence alone isn't definitive proof of a ninth planet, prompting heated debates. The community recognizes that unconfirmed indirect clues may be subject to observational biases or alternative explanations, such as the presence of multiple smaller objects or an uneven distribution of mass in the outer solar system. Still, some researchers, equipped with advanced telescopes and powerful data analysis tools, continue chasing faint signals in the darkness, convinced they're glimpsing only the beginning of a larger story. Public reactions, meanwhile, are colored by a deep sense of wonder. The idea of a colossal planet hiding in our solar backyard captures the imagination of those who grew up marveling at the night sky. Stories of NASA's ongoing searches resonate with a sense of adventure, a modern detective story involving cutting-edge technology and international collaboration. Popular culture, from science fiction books to documentaries, amplifies this excitement, creating a ripple effect that keeps the suspense alive. Yet, amid this enthusiasm, there's also a layer of skepticism among skeptics who question whether the available evidence can hold up under scientific scrutiny or if the entire pursuit is partly fueled by the media's tendency to sensationalize the unknown. NASA's carefully worded statements seem to walk a tightrope, fostering curiosity without promising certainty. By continuously releasing data, perhaps even suggestive hints, they sustain an aura of mystery that makes the quest for Planet 9 feel like a cosmic whodunit. Months turn into years, and each new discovery or null result sparks fresh debates. Some experts believe that confirming the existence of such a planet could revolutionize our understanding of planetary formation and the dynamics of our solar system. Others warn it might turn out to be an elaborate mirage, a gravitational footprint misinterpreted, or a product of current technological limitations. The collective hush surrounding NASA's ongoing research only deepens the mystery, leaving everyone eagerly awaiting the next chapter in this enigmatic celestial puzzle. Deep within the vast emptiness of our solar system, a mysterious gravitational influence hints at something colossal lurking beyond Neptune. What many speculate to be a hidden planet, often referred to as Planet 9. Despite the lack of direct observation, astronomers have pieced together compelling evidence through subtle orbital anomalies displayed by objects in the Kuiper Belt. These discrepancies suggest the presence of a massive body exerting gravitational pull, a force that appears to shepherd distant icy bodies into specific orbital patterns. NASA's precise tracking of celestial motions has bolstered these hypotheses, hinting at a presence that could weld the outer solar system into a coherent, yet enigmatic structure. Scientists are particularly intrigued by the elongated and clustered orbits of distant Kuiper Belt objects, which resist explanation by known planetary bodies alone. Data collected from telescopes like the Subaru telescope and Pan-STARRS reveal that these objects are moving in ways consistent with perturbations caused by a planetary mass object hundreds of astronomical units away from the Sun. The implications are enormous. If these orbital behaviors are indeed due to an unseen planet, its mass could rival that of Neptune, making it the most massive undiscovered object in our solar system. This raises fundamental questions about the formation of planetary systems and the dynamic evolution of our cosmic neighborhood. NASA's role in this quest remains pivotal. The agency's advanced observational instruments are continuously scanning the farthest regions of the solar system with unprecedented sensitivity. Although no definitive visual confirmation has yet been achieved, ongoing surveys are refining the possible location of Planet 9, narrowing down the search area incrementally. The uncertainty fuels a sense of suspense, as every new data point could be the key to unmasking this elusive giant. NASA's commitment, combined with international collaboration, underscores the scientific community's determination to decode a cosmic riddle that could redefine our understanding of planetary science. The stakes involve more than just discovering an unseen planet. Confirming Planet Nine's existence would challenge existing models of how planets form and migrate within protoplanetary disks. It could also shed light on the history of our solar system, possibly revealing secrets about its early, tumultuous years. As NASA and astronomers continue their meticulous search, the anticipation builds. Each observation, each calculation, pulls us closer to either revealing a new world or understanding why the cosmos sometimes keeps its most profound secrets hidden, deepening the mysterious allure of what might lie beyond the reaches of our current sight. As we've unraveled the hints and mysteries surrounding Planet Nine, one thing remains clear: NASA's ongoing exploration continues to challenge our understanding of the cosmos. The evidence pointing toward a hidden giant lurking on the fringes of our solar system is compelling, yet the full picture still eludes us. What's certain is that NASA's advanced telescopes and scientific missions are pushing the boundaries of what we thought possible, promising groundbreaking discoveries in the coming years. If you've ever looked up at the night sky and wondered what secrets it holds, you're not alone. This relentless pursuit of knowledge fuels NASA's quest, and it could ultimately redefine our place in the universe. Stay tuned. Our journey into the unknown is far from over. Make sure to subscribe and keep watching, because the next chapter in Earth's greatest cosmic mystery is just around the corner. The universe's secrets aren't finished revealing themselves yet, and neither are we.